What's up, guys? In this video, what I want to do is go over 5 examples to determine if they are a polynomial or are they not a polynomial. And obviously, to be able to determine if something is a polynomial, we need to understand what exactly is a polynomial. Now, as a math teacher, I could definitely give you a more boring and mathematical definition of a polynomial, but I'm going to try to skirt around that as best I can. So therefore it can kind of make sense to you. And we don't have to kind of like get confused going over the proper definition of a polynomial. Now, a way to think of the polynomial is going to be a sum of monomials. Now, you can think about a sum of monomials like y is equal times a x raised to the k. Like that is a monomial. So you can think about like adding just another one of them or another one or another one. And again, you can think of like subtracting and being the same thing. Like that just be like adding a negative. Okay. But the important thing here is coming into a is a real number and k represent a real number. Okay, now I'm just going to do the dot, 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 because if you look at like the formal definition of a polynomial, they start to use subscripts. And I think for most students, like it just kind of goes above their head and just gets way too confusing. Here is a monomial, right? So a x to the k, that is a monomial. If you have more than them, right, adding a sum of them or adding negatives of them, whatever, then that is going to be a polynomial. So if you have more than one, we call it a polynomial. And obviously you can even have one of them. It's still considered a polynomial. So what makes a polynomial and what does not make a polynomial? So some of the key characteristics is going to be coming up with this k, okay? The a actually is not going to impact it at all. What we're going to be focused on is k. What are these numbers, okay? So k cannot be negative, all right? So if you have a negative number, then k is, if you have k representing a negative number like -5 or -2, then you do not have a polynomial. Now, it's also important to what happens when we have like a negative number? Well, go to your rules of operations. Like if I have 2, or I'm sorry, let's say like 2 raised to, actually, let's go back to variables. I like that. If I had a raised to the negative m, I could rewrite that as 1 over an a to the m. So what that also means, or another definition a lot of times we talk about, is you can't have a negative exponent. You also can't have your exponent in the denominator. Okay, so you can't have negative powers and you can't have an exponent in the denominator because they're basically exactly the exact same thing. And the reason why that's the case is because then you're going to invoke some discontinuities possibly, and a polynomial is a smooth and continuous curve. Now, the other thing that we know that our k cannot be a fraction. Okay, so k cannot be a fraction. So therefore, it can't be like 1/2 or, cannot be, 1/2 or 3/2 or 2/3 or whatever may be the case. And again, going back into like our understanding here, if a is equal to a m over an n, like let's say it's a fraction, well, remember that represents the nth root of a to the m power. Okay, now again, why do we not want it to be radicals? Well, if we have it in radicals, again, that's going to break up this idea of this smooth and continuous curve. And you can just look at these with these power functions. You can see how that is now going to impact it. All right. So now, hopefully you recognize these. It can't be negative, it can't be a fraction, it can't be in the denominator, and it can't be under a radical. Those are kind of like our ideas. And again, the big tip is, guys, this only works for k. Okay, we're not going to be considered about this for a. So let's go into these first couple examples and see if our properties of a polynomial is violated or not. So the first example, I'm going to use function notation, is going to be a -3. Now again, notice there's only one of them, so you could say it's a monomial, right? But again, is it raised to a negative power, right? Do you have a variable raised to a negative power, or do you have a variable raised to a fraction? And the answer is no. So guess what? This is a polynomial. Even though there's not more than one monomial, we still consider it a polynomial. Number 2. What about if I have f of x equals a 1/2 minus a 9x? Now, some students will look at fractions like, I hate fractions, -9. But again, like I have negative, my a is negative, but my exponent's not negative. So again, this is going to work, polynomial. Okay, so that is, again, an example of a polynomial. What about this example? If I have a f of x is equal to a 2x to the -7th plus 5. Okay, and hopefully you recognize here, guys, that this is not going to work. You can't have a variable raised to a negative power, so therefore this is not a polynomial. Okay, now another way that this also could be written, which would still be wrong, if it was 2 over a x is 7th plus 5. Okay. Again, that's another way of representing that. And you say, oh, it can't be in the denominator or it can't be negative power. Same idea, but they're both not going to be polynomials. What about this one? So if I had f of x equals a 5x squared, I still got room, right? Yeah, okay. Minus a 2/3 x minus a 7. Okay, so in this one, again, students see like the fraction, or they see the negative. Like they're like, oh, we can't have a negative in the denominator. Yeah, but guys, remember, it's only for powers. So again, this is x squared. This is x to the first power. We're not dealing with any fractions in the numerator, in the powers or negatives. So therefore, this is a polynomial. Okay. And then let's see, number 5. Let's say I have a f of x is equal to a square root of 2 x to the x squared. Oh, as a x squared minus 1. So in this case, now again, this one's a very confusing one because a lot of students see the square root and they're like, oh, actually, I'm sorry. Yeah, it was 1 to the, that's what it was. 1 to the 1/3 power, which is very confusing. Actually, no, it wasn't 1/3 power. Sorry. It was 2 to the 1/3 power. Okay, so if you look at this problem, you're like, what? And so you're like, all right, well, we have fractional powers and we have a square root. So there's no way this is a polynomial. But again, guys, we're only worried about k, right? K is the power of your variable exponent, right? Which we don't have. The only power to our variable exponent in this case is 2. So this is an a, right? And this is just a constant. This is not impacting our graph at all. Like this can be a radical. This can have a negative power. It does not matter, right? We're only concerned about our 2, our k. So in this case, this is actually a polynomial. And then our last example here is what if I have an f of x is equal to a 4x to the negative 5x to the negative 2/3. Okay, ran out of space. So I knew it was going to happen. So crap, not that way. Let me go do it. There you go. Okay, so hopefully you guys recognize in this case, you can see that not only is this raised to a fractional power, it's also raised to a negative power. So therefore, this is actually not going to be a polynomial in 2 different ways. 1, because it's a fractional power, and then 2, it's to a negative power. So therefore, this is not a polynomial. Okay, so there you go, ladies and gentlemen. Hopefully this video was helpful for you. And if it was, I look forward to seeing you in the next video. Cheers.